Okay, you guys, this is tough. This right here is tough. It's kind of like that dot plot thing from last chapter. I do lose a lot of people the first time I go through this, so focus up. All right. Here's an example. I think Brady is a guy who plays basketball, so I'm going to say Brady, and he claims he's a 79% free throw shooter, which is a pretty decent percentage. Then in the next game, he goes out and he makes 6 out of 13 free throws. Should we call Brady out as a liar? Well, this question is just like the question we had last chapter. Is this good evidence that Brady is not a 79% free throw shooter? I mean, doesn't that mean the same thing as should we call him out as a liar? That's a tough question. Like, if he's a 79% free throw shooter and I ask you what's the probability he makes this one free throw, well, the answer is easy. Well, yeah, he's got a 79% chance. But if I start talking about 13 free throws and what's the odds of him making 6 out of 13, that gets real complicated in a hurry. It makes your brain hurt a little. So I'm going to show you some steps to go through and pick random digits so that we can approximate that probability. Okay? Here are steps to using simulation to answer a difficult question. Ready? Step number 1 and step number 2 are probably the weirdest for you to get used to and the most important. Number 1, use the given probability and assign digits to represent one chance process outcome. I'm not going to send Brady out to shoot free throws all day. That doesn't make sense. It takes too long. Although Brady would happily leave class and go shoot free throws all day, let's be honest. And most of you would enjoy leaving class to go watch that, especially if we can heckle. Anyway, use the given probability, 79% is my probability, to assign digits to represent, as if this is true, one chance process. So here's what I'm going to do. I'm going to take 2-digit numbers randomly, right? Like from that random digit table in the back of the book, or I'm going to use my calculator to do it. I'm going to assign here, right? So let 00 through 78 equal a made free throw, and let 79 through 99 equal a miss. See what's going on there? If he's at 79% chance of making the free throw, give him 79 2-digit numbers. And if he's got a 21% chance of missing, give him 21 misses. Then go start taking 2-digit numbers. Ready? Do I have my calculator here? I don't have my calculator next to me, so I'm going to go to this random digit table. Right? I'm calling a timeout. I just want this to make sense as I go, because this whole 6-step process is definitely weird. Where is... I went too far. Sorry, it's all the way in the back here. Nope. There it is. Okay, you randomly pick a line. So let's start at 114. Now I'm going to take a 2-digit number. Ready? The first 2 digits I see on what did I dang it, I just 114. The first 2 digits are 45. Okay, let's go look at how I assign them. 45 is a made free throw. So the first one he makes. Then look at the next 2 digits. 14. 14, he makes another one. Let me go to the next 2 numbers. That's a 9 and a 3, so that's 93. That's a miss. Brick. Nice job, Brady. And then go to the next one, 29. That's a make. 92. That's a miss. 75. 75 is a made free throw, and so on. That's me assigning digits so that we can tell what's a made free throw and what's a miss. Now, number 2, describe how many sets of 2-digit numbers you got to take in order to talk about this scenario here. How many free throws are we talking about Brady shooting? 13 of them. So to simulate one trial is what we call it. And so I'm going to say that we will take 13 2-digit numbers to represent 13 free throws. The amount of time it would take me to go through those 13 numbers in the back of that book versus the amount of time it would take Brady to shoot 13 free throws is much more efficient. In the first place, he's got to dribble a couple of times. He's got to go through his process, make a smart-ass comment. It's going to take forever. Anyway, number 3. Now that I have assigned numbers, and now that I've said how many I'm going to take, you define how you determine if each trial is a success or a failure. And there's other kind of problems where it's not a success or failure. You're actually going to get a number out of it, but we'll talk about those if we run into them. So a success or a failure, I'm looking for how often, if this is true, Brady would make 6 out of 13 or worse. I want you to know that's a thing we do. It doesn't make sense at first, but 6 out of 13 or worse. So here's how I'm going to define that. If 6 or less of the 13 two-digit numbers, if 6 or less of the 13 two-digit numbers are made free throws, label the trial a success. Okay, why do I call it a success? Because I'm looking to see when this will happen, right? 6 out of 13 isn't a very successful bunch of trips to the free throw line for Brady. If he thinks he's a 79% free throw shooter, this is less than 50%, right? But we're looking to see how many times this happens. So in this string of things, we're going to call that a success. If he makes more than 6 of them, that's a failure. Now, describe how you will obtain your random numbers. Okay, take two-digit numbers from, what did I use, line 114, I think, line 114, or we could do this. We could do random integer on our calculator that goes 0 through 99, and we want 13 of them. That would just generate 13 random numbers for us. Now here's another important one. This stone ties in with these two as being the hardest thing to understand. I don't just go get 13 two-digit numbers once. That just shows me what happens in one string of 13 free throws. It doesn't give me a long-term look at the behavior. So you're going to state how many trials you will actually use for your simulation. So we'll take, oops, that's not how you spell that at all. We'll take 13 two-digit numbers and call them a success or failure .500 times. I'm going to go out and get 500 sets of 13 two-digit numbers. That's going to be a whole bunch of successes and failures. But that's a big long-term number so that I could start to zero in on the actual probability of Brady going 6 out of 13 or worse. Now, of course, in class, we're never going to do something 500 times. We're going to shorten that up just because it's insanity to do something 500 times. But maybe during one of our classes, every one of you guys can do something like 10 times, and then we can put them all together and get a bigger number. After that many trials, you estimate your probability as the number of successes. This part should make sense to you over your total number of trials. You guys, that's one problem right there, right? A 6-step problem for estimating a complicated probability as opposed to using probability formulas, which we'll also learn later on. But we're going to need some practice with this. You can't just watch the notes and go, oh, yeah, got it, and then think that that's going to go well if I put that on the test. So we're going to need some practice with that. I got one more page of notes, I think, for this section, so let's stop the video now and go to the next page.